Hello and welcome. We often think about behavior pretty simply. You do something, you get something. But what happens when the rules for getting that something get a little more complicated? What if there are multiple rules going on at once, or you have to follow a very specific series of steps to get a reward? Well, today we're going to dive into the really fascinating world of compound schedules of reinforcement and uncover some of these hidden rules that shape our behavior every single day. So here's how we'll break it all down. First, we'll start with the basics. What exactly are compound schedules? Then, we'll look at how we make choices when we've got a few different options available at the same time. After that, we'll see what happens when the rules change on us, sometimes with a clear signal and sometimes not so much. We'll wrap up by exploring schedules that require a specific sequence of actions, and then we'll pull it all together with the key takeaways.
All right, let's jump right in. To really understand how these more complex schedules work, we first need to get a good handle on the fundamental building block they're all made of.
So at its core, a schedule of reinforcement is really just a rule. It's the set of conditions that spells out when a certain behavior is going to be rewarded. It could be based on how many times you do something, or maybe how much time has passed. The thing is, these rules are absolutely everywhere.
This is where it gets really interesting. Life is rarely governed by just one simple rule, right? Most of the time, we're navigating environments where multiple systems of reinforcement are going on all at once, or one after the other. And that is the essence of a compound schedule.
Okay, let's start with the schedule that is all about choice. This one is called the concurrent schedule, and a great way to think of it is as the choose-your-own-adventure of reinforcement.
The keywords to focus on here are independently and simultaneously. In the concurrent schedule, you've got multiple options, and each one has its own rule for reinforcement. The important part is that they're all available at the exact same time, and you're totally free to switch back and forth between them whenever you want.
So the most important things here are that simultaneous access and the total freedom to choose. This setup, as you can imagine, is perfect for studying how we make decisions. It's actually the foundation for something called the matching law, which is just a way of saying that we tend to put our effort where we get the most reward. So if one video game gives you points twice as often as another, you're probably going to play that first game about twice as much. Makes sense, right? And this is a perfect real-life example. Think about it. Right now, you could be texting a friend, which gets reinforced when they reply, or you could be playing a game on your phone, which is reinforced by winning points. Both of those schedules are running at the same time, and you get to choose where you want to invest your time and effort.
Now let's move on to our next section. Here, we're going to compare two schedules that are actually very similar, but they have one critical difference: the presence or absence of a signal.
But before we can compare them, we need to define this really important term, the discriminative stimulus, or SD for short. Just think of an SD as a signpost. It's a cue in the environment that basically tells you, hey, this is the rule that's active right now. And this slide lays out that key difference perfectly. On one side, you've got the multiple schedule, where there's a really clear signal, like a traffic light, telling you which rule is in play. So a green light means one set of rules is active, a red light means another one is. But on the other side, you have the mixed schedule. Here, the rules still change, but it's like the traffic light is broken. You're just left to figure things out on your own, without any clues.
I think this analogy makes it super clear. A multi-schedule is like climbing a mountain, where there are helpful signposts telling you what to expect on the next part of the trail. A mixed schedule is like climbing that exact same mountain, but the trail changes abruptly and without warning. There are no signs to guide you at all.
And this quote really drives the point home. For a multiple schedule, that SD isn't just a feature, it's the defining characteristic. The presence of that signal is what makes it what it is.
And of course, on the flip side, the defining feature of a mixed schedule is the absence of that signal. It's kind of like the mystery mode of reinforcement, where the rules change on you without any external heads up.
All right, on to our final type, the chained schedule. Now, unlike concurrent schedules, which were all about simultaneous choice, chained schedules are all about sequence and order.
The key here is the sequence. Think of it like a treasure map. You have to follow a series of steps, and you have to do them in a specific order. You don't get the treasure, the big reward, until you complete that very last step. Each step you finish just gets you to the next clue on the map.
Making a sandwich is a perfect everyday example of this. Getting the bread is your first step. Completing that step acts as the signal, the SD, to start the next step, adding the ham. This keeps going until the whole sequence is done, and only then do you get the final or terminal reinforcer, eating the delicious sandwich.
And this is the really clever part of a chained schedule. When you finish one step, it actually does two things at once. It's a small reward for what you just did, and it's the signal to start the next step. But that big prize, the main reinforcement you're working for, is saved until the very, very end.
Wow, okay, we've covered a lot of ground. So let's take a moment to pull everything together with a quick recap, just to make sure these concepts are locked in.
This table really helps bring it all together. If you look closely, you can see the key patterns. Concurrent is the only one that's simultaneous. It's all about choice. The other three are all sequential. And that big difference between multiple and mixed, it's all about the presence of signals. And finally, what really sets a chained schedule apart is when you get the reward, only at the very end.
And to make these even easier to remember, here are a few simple ways to think about them. For concurrent, think competing choices. For multiple, think multiple SDs. For mixed, it's mystery mode, because there are no signals. And for chained, you have to complete the chain.
So if you're ever trying to figure out which schedule you're looking at in the real world, just use this simple checklist. First, ask yourself, is this about making a choice right now, or is it a sequence of steps? Second, are there clear signals telling me what's going on? And finally, do I get rewarded along the way, or only when I'm completely finished? The answers to those questions will point you straight to the right schedule.
And that's really why this all matters. These aren't just abstract concepts from a textbook, they are the underlying architecture of our behavior. By understanding these schedules, we get this incredible insight into why we make the choices we do, what keeps us going through a tough challenge, and how we learn complicated multi-step skills. They really are the invisible rules that govern so much of what we do every day.